Hi folks, Antonio here once again, going back with this YouTube channel. Today we're going to talk a little bit about the basics of computing. So without further ado, let's get on with it.
Okay, so basics of computing, the binary system. Okay, you might have heard somewhere that in terms of computing, in terms of the hardware, what your computer understands, what your cell phone, which is also a computer, understands, there are only ones and zeros, right? However, I would argue that there aren't even ones and zeros in the hardware of your cell phone, in your computer. Yeah, what does exist is energy and lack of energy. So we've got a little drawing here. Okay. Um, think of these squares as a very, 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 very small portion of your computer. Okay. And we, as programmers, we give certain instructions to our computers which at the very hardware level are going to be interpreted as okay, so this small piece of hardware here, we're going to put some energy here. Okay, some electric current is going to be present here. Oh, but in this other portion here, we're not going to put electric current. Okay, so this is everything that your computer understands, quote unquote, because your computer isn't really an intelligent machine, right? So in the very, very early stages of computing, of computer science, right? Some very, very clever people decided that, hey, what if we represent energy, okay, that is going to pass through very, very small bits in our computer. What if we represent energy as 1 and lack of energy as 0, right? And what are ones and zeros? Ones and zeros are numbers. Do you agree with me? And as numbers, they are abstractions. So as abstractions, okay, they are, let's say, artificial, okay? They don't really exist in nature apart from humans. They depend on humans. We don't see numbers, running on the street or anything like that. We can represent numbers, we can draw numbers, we can type numbers, but they don't really exist in nature, quote unquote. Okay, this is a kind of a philosophical concept, but yeah, they don't exist despite of humans. They are abstractions created by humans to quantify and represent concepts in nature. Just like words, words are also abstractions. Do you agree with me? So this is the first layer of abstraction. We're representing energy as 1 and lack of energy as 0. Okay? So, what we are going to do now is we're going to start counting, okay, using zeros and ones. In other words, the binary system. Why binary? Because two digits, okay? We're going to use two digits, 0 and 1, in order to count, okay? Generally speaking, actually 99.9% of the times, we use the decimal system. Why decimal? Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. Okay, this is why it's called the decimal system. And there are other ways of counting as well. In the future, actually, in fact, in the very near future, we're gonna use the hexadecimal system, which uses 16 digits. Okay, so yeah, we are used to counting with the decimal system, but as programmers, we're gonna start to get used to counting as well with the binary system because it fits very, very well with the architecture of computers, right, of how computers are designed, okay? Certain bits are called, we're going to call them ones, and other bits, we're going to call them zeros. If there is energy going through them, we're going to interpret them as one. If there's no energy going through them, we're going to interpret them as zero. But in order to be able to count with ones and zeros, where I'm gonna take a step back with you, and let's explore how the decimal system, which is the system that we are used to, let's explore how it works a little deeper. Okay. Okay. So if you guys allow me to hide myself a little bit, um, we have here our decimal system. We're going to represent a few numbers. In each place here, you can see that we've got our 10 digits. Okay, so right here we've got 10 digits, 10 digits, 10 digits, 10 digits. Okay, if I want to represent, let's say, the number 0, all I have to do is like, well, so 0 only occupies one space, so I'm gonna grab the number 0 and I'm gonna put it here. I'm gonna put it here. Okay, so far so good, easy, right? Okay, if I want to represent the number 1, same thing. I'm gonna put 1 here. Number 4, same thing, 4 here. If I want to represent 9, okay, I'm gonna put 9 here. So you guys imagine that there is number 9 here. Okay, but if I want to represent number 10, oops, I've ran out of digits. So I need to go to the next house, to the next place. So I need to grab the number 1 here and I'm gonna put it right here. Okay. And if I want to represent the number 11, well, the number 11 doesn't occupy 3 houses. Do you agree with me? So I can just, grab the number 1 and put it here. And same thing for number 12, right? For number 19. Okay. And now we've got the number 19 here. If I add 1 so I can get the number 20, okay, then all of a sudden I'm going to put 2 here and 0 here. Do you guys agree with me? So using two houses, the greatest number, okay, two houses, the greatest number that I can represent in the decimal system is the number 99. Do you agree with me? Okay. All right. And if I want to represent the next number, so say that I add 1 here, the next number, I'm going to have to go to the next house. Okay. I add 1 here. All of a sudden, I have 100, so 100, and so I need the next house. So I have my number 100 here, as you can see. Plus 1, 101, plus 2, 102, okay? So what is the greatest number that we can represent here? That's right, 999. So 999. Okay, so we have our 999 here. Okay, so that's the greatest number that we can represent in 3 houses. So you guys get the idea, right? In order to represent the next number, I'm going to need another house, the 4th house, so 1000, and so on. You guys get the idea already, right? So another way that we can represent the same idea, okay, so let's get a little deeper, is, guys, any number elevated to 0. So, for example, 1 elevated to 0 is the number 1. Do you guys remember that from your math classes in high school? 2 elevated to 0 is also 1. The number, I don't know, 100 elevated to 0, excuse me, it's a little ugly here, is also 1. So any number elevated to 0 is 1, including the number 10. So 10 elevated to 0, okay, to the power of 0, is also 1. So say that I want to represent, for example, the number 4 using this idea, okay? Represent number 4, 4, okay? 10 elevated to 0 is 1, right? So 10 elevated to 0, okay, times the number that we have here. So which number represents number 4? That's right, the very own number 4, okay, times 4. Okay, so this results in 1 times 4, which is the result, number 4, okay? It may sound a little silly, but you guys are gonna see where I'm getting at. Okay, so let's number 9, same thing. 10 elevated to 0. What is the amount of tens elevated to 0 that we have on number 9? That's right, we've got 9. We have 9 tens elevated to 0, okay, which is going to result in our number 9, okay? So we can multiply 10 elevated to 0 by the digit that we want in order to get the amount of tens elevated to 0 that we have, okay? So from now on, we're going to think about this as the amount of tens elevated to 0 we have. What's the result of 10 elevated to 0? That's right, it's 1, okay? And if we go to the next house, the next place, we're going to call this 10 elevated to 1. So what is the amount of tens elevated to 1 we have? So for example, let's say we have number 10 here, okay? So we have number 10. What is the amount of tens elevated to 1 that we have here? Remember, any number elevated to 1 is itself. Okay, so 2 elevated to 1 is 2. 4 elevated to 1 is 4. 1,000 elevated to 1 is 1,000. Okay, so what is the amount of tens elevated to 0 that we have here? Well, we have 1. Sorry, what is the amount of tens elevated to 1 that we have here? We have 1, 10, elevated to 1, okay? And what is the amount of tens elevated to 0 that we have here? Well, we have 0. Okay, so we have 0 tens elevated to 0. Okay, sorry, it's a little ugly here. Okay, so 1 times 10 elevated to 1 plus 0 times 10 elevated to 0, because we have no tens elevated to 0 here, but we have 1 10 elevated to 1. So this is going to be 10 plus 0, which is the result that we want. Okay? Another example, let's say that I want to represent the number 37. Okay, how can I represent 37 using this idea? Well, what is the amount of tens elevated to 1 that we have? Well, we have 3 tens elevated to 1. And what is the amount of tens elevated to 0 that we have? Well, we have 7 tens elevated to 0, right? Okay, so it's a little ugly, but you guys are getting the idea. Okay, sorry about that. So 3 times 10 elevated to 1 is 30, plus, well, 7 times 10 elevated to 0 is the same as 7 times 1, right? So, okay, sorry, 10 to the, 10 to the power of 0. Okay, so I'm kind of, translating from Portuguese here, okay? Which is the result that we want. Okay, so by this point, I think you guys get the idea, right? The first house is 10 to the power of 0, 10 to the power of 1. So logically, the next one is going to be 10 to the square, or 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, and so on. All right? So let's say that I want to represent 7,481. How do I do that, right? What is the amount of tens? Because we have four houses here. Do you agree? So the fourth house is 10 to the cube, 10 to the power of 3. So what is the amount of 10 to the power of tens to the power of 3 that we have? 7. We have 7 tens to the power of 3, so 7 times 10 to the power of 3 plus the next house. So what? So the next house is 10 to the square, right? 10 to the 10 to the square, 10 to the power of 2. So what is the amount of tens to the power of 2 that we have? We have 4. What is the amount of tens to the power of 1 that we have? We have 8. And finally, what is the amount of tens to the power of 0 that we have? We have 1. Okay, so the result is going to be 10 times, sorry, 7 times 10 to the cube. So 10 to the cube is 1,000, right? So 7 times 1,000, right? Plus 4 times, so what is 10 to the square? Well, 10 times 10, so 100 plus. And guys, this is a little ugly, so sorry about this, but I think you guys are getting the idea. If you're not, please tell me in the comments. 8 times, what is 10 to the power of 1? It's 10. Right, so 8 times 10 plus 1 times, well, 1 times 1. Do you agree? 1 times 1. This is going to be, the result is going to be 7,000 plus 400 plus 80 plus 1. And if we sum this, it's going to be our number 7,481, number that we wanted to calculate in the beginning, right? That we wanted to represent using this system here that you guys can see. Alright guys, so by this point the video is long enough. Thank you very much for watching it. Alright, I'm gonna stop the video here. And in the next video, we're going to apply what we've discussed about the decimal system to the binary system. We're gonna apply the same idea to the binary system. Okay, so join me for the next video. And yeah, and Dolores is here as well, and she's also wishing you guys to have a great week and a great day. Okay, cheers.